Okay, here is a real quick review if you missed when I introduced the stoichiometry. Stoichiometry is just a ratio, just like a recipe. I love this quote by H.J. Grant. I believe it's from Emerson originally. That which you persist in doing becomes easy, not because not the nature of the thing has changed, but the power and ability to do so has increased. Okay, we're going to start with number 1 here. I'm going to have you balance the equation. If you're watching this on video, go ahead and pause this at this point. Try and balance this equation on your own and then come back. All right, remember with balancing equations, we're going to want to put cho down the center here. And I would bump up a piece of scratch paper to do this. You're going to take, and on the left-hand side you have 4 carbons. On the right-hand side you have 1. So I'm going to use a coefficient of 4 to make that 4. On the left-hand side, I've got 10 hydrogens. On the right-hand side, I have 2 hydrogens. So I need to make that 10, so I'm going to have to times this by 5. Whoops, now I've got 10. Okay, on the left-hand side, I've got 2 oxygens. On the right-hand side, I've got 4 times 2, which is 8, plus 5 times 1, which is 5, adding up to 13. That's an odd number. I only can get even numbers on the left-hand side, so I have to do a little trick. And the trick is to times this by 13 halves. So if I times 2 by 13 halves, the 2's will cancel and I'll end up with 13. So for just a second, that is balanced. Now I'm going to take the eraser and I'm going to erase this stuff down here because we know this equation is balanced now. Whoa, well, it was balanced. Let's go back. There we go. Nice thing for undo. Okay? But we can't leave it that way. So what we're going to do is we're going to go through and times everything through by 2, just like you would an algebraic equation. So I get a 2, a 13, an 8, and a 10. Okay, now we have a balanced equation. We're going to use the ratios. So this is how I would like you to set these ratios up. On this first one, A, it asks for C4H10 to O2. C4H10 is butane. So I would like you to take and look up at the equation in front of butane. There's a 2. That means there's 2 moles of butane for every, now we look at oxygen, 13 moles of oxygen. Okay? I want you to set up the rest. Well, let me do D with you. I'll do one more. So on C4H10, again, we've got 2 moles of C4H10. And on the bottom, we would have CO2. In front of CO2, there's an 8. So 8 moles of CO2. So I want you to set up the rest of the ratios for me. So go ahead and pause the video and then come back. All right, let's bring up, let's go ahead and balance this second one down here. The second equation, again, pause the video. If you need to, quickly balance it and come back. All right, you're back. So we've got 3 oxygens on this side, 2 oxygens on this side. Common factor is 6. So I'm going to make a 2 and a 3. Then that messes up my potassiums and chlorines, which were balanced before, so I need to put a 2 there to balance it. We've got a balanced equation now. Now we're going to go back and we're going to start talking about my brain just left. Okay, about factor label or dimensional analysis. Personally, when I do stoichiometry problems, I like to read the problem, and underneath my balanced equation, I like to put the information they've given me, or what they want. So as I'm reading this, how many moles of O2? So I put a question mark underneath O2 and put moles, because they want me to find how many moles of O2. Underneath the KClO3, I'm going to put the 12 moles that they gave me. And I'm sorry this isn't writing really small here, but that does say 12 moles. All right, so then I start a factor label with what they've given. 12.00 moles of KClO3. Start your factor label. Now we're going to set a ratio just like we did in part 1. We want to get rid of KClO3, so it's going to go on the bottom. So on the bottom I'm going to put 2 moles of KClO3. On the top, I'm going to put what I want to get to, which happens to be oxygen, and there's a 3 in front of it, so for 3 moles of O2. Man, I can quickly cancel out moles of KClO3. I can take 12 divided by 2 is 6, times it by 3, that's 18. I have 4 significant figures to start with, so I end with 4. I don't forget to put my units, which are moles of O2. Circle or square your answer. Okay, going on to number 3. Again, take the time, balance the equation. If you pause it real quickly, and come back. Should have been fairly easy to balance, just putting a 2 in front of K and 2 in front of KCl. Now, again, as I read it, I put question marks underneath about what they want. So how many grams of KCl? Question mark, grams. Is produced from 2.5 grams of K. 2.50 grams. And excess Cl2, excess. Now excess just means I don't need to worry about the Cl2. So, starting factor label with what I've been given. Let me use a different color. That doesn't show up very well. Green worked really well. Let's do that. 2.50 grams of K. Now, I can't jump right into the ratio because in order to use the ratio, I have to be in moles. So I need to go back to my mole map, and I say, okay, in 1 mole of potassium, if I look up on my periodic table, there are 39.098, I believe, yep, 098 grams of potassium. Then I can cross out grams of potassium. Now it's factor label or dimensional analysis because I'm keeping track of the labels. The next step is I go and I use those coefficients here and here. So for every 2 moles of potassium, I get 2 moles of potassium chloride. At this point, I can cross out moles of potassium. Now, it asks for grams. Now you need to use the mole map to go backwards. So last conversion here is to go from 1 mole of potassium chloride 2 grams of potassium chloride, and I would need to add up potassium and chlorine. Okay, that is 74.551. Now, we can cross out moles of potassium chloride and moles of potassium chloride. We can also cancel out the 2's. So now all I have to do is take that 74.551 times it by 2.5 and divide it by 39.098. We had 3 significant figures to start, so we have 3 to end with. We end up with 4.77 grams of KCl. Circle or square your answer. Okay, the rest of the worksheet is yours to practice this. Sometimes you'll need 4 conversions, sometimes you'll need 1, and sometimes you'll need 2. Just remember to balance the equation first. Good luck.